oxidations and reductions in terms of change of oxidation number. Now, the very first thing that we need to know is what does it mean by oxidation states or oxidation number? Oxidation state shows the total numbers of electrons which have been removed from an element or added to an element to get to its present state. For examples, let's say we have a sodium. Yeah, let's say we have a sodium, Na. Now, for any atom or elements, the oxidation state is 0. Okay, so this is neutral. Okay, it's neutral, and then it's element. Neutral elements, then the oxidation state is 0. Okay. Now, if this sodium it loses electrons, okay, if it loses electrons, sodium is from group 1. It will lose 1 electrons. What's the charge of this sodium ion if it loses 1 electrons? It loses 1 electrons, the charge will be positive 1, yes. Okay, so the charge will be positive 1. Okay, so if we have electrons removed, okay, 1 electron removed, then the oxidation state become positive 1. Okay, that's the oxidation state. Okay, so if you have electrons removed, okay, or if there's electrons added, for example, oxygens, if it's it gain 2 electrons, so the charge become 2 negative, okay, and the oxidation state will also become negative 2. Okay, so that is oxidation state. Oxidation state tell how many electrons removed or added to an element to the present state. This is the present state. This is the previous state. This is the present state. This is the previous state, and this is the present state. Okay, so that is what does it mean by this oxidation state. Okay, actually from here we can see that we can tell the oxidation state by referring to the charge. If we know the charge, this is for a single ion, the simple ions. For the simple ion, if we know the charge, then we can tell the oxidation state by referring to the charge. This one positive 1, so the oxidation state positive 1, and this one negative 2. So the oxidation state is negative 2. Now, one important thing that you need to know is, for oxidation state, you must tell the positive or negative sign. For example, the oxidation state is positive 1. So in exam, if you write 1, then wrong. Okay, mark will be deducted. So you must tell the positive or negative sign of this oxidation state. Okay, negative 2 usually you write negative 2, but for some students, positive 1 they just write 1. Okay, if you write 1, then no marks. Okay, you must tell positive or negative. Okay, so that is for oxidation state. Working out oxidation state. How do we know the oxidation state of an element? How do we know? Okay, now there are a few rules that you need to memorize, and make sure that you memorize. This is the most important things that you need to know in this chapter. Okay, so there are a few rules that you need to memorize. The first one, the oxidation state of an element is 0. Okay, for examples, magnesium is element, zinc is elements. Okay, oxygen is elements, hydrogen is elements. Okay, as long as it consists of just one types of atom, then it's elements. Okay, is carbon dioxide an element? No. Why? Because there are 2 types of atoms, right? 2 types of atoms, then it's not element. Okay, so for element, the oxidation state is 0. For examples, magnesium, hydrogens, bromine, all of these are elements, right? Okay, so therefore the oxidation state is 0, 0, 0, 0. Okay, so element, always remember the oxidation state of element is 0, not ion, just element. Okay, 0. For simple ions, for example, magnesium Mg2 positive, this is simple ion. Hydroxide, this is not simple ions. There are 2 elements in the ion, then it's not simple ion. Simple ion means there's just 1 element in the ions. Okay, now for simple ions, the oxidation state is equal to the charge. Okay, the oxidation state is equal to the charge. Let's see this table. Okay, now, so we have copper ions, bromide ions, oxide ions, and aluminum ions. So What's the oxidation state of these copper ions? +2, okay? You must tell the positive or negative sign, okay? But anyway, that's correct, okay? Bromide, what about bromide? What's the oxidation state? -1, that's correct. -1. Oxide actually 2 negative is here, okay? 2 negative is there. Okay, oxide, -2, that's correct. Aluminium, +3, that's correct, okay? Because the charge is 3 positive, right? Okay, so +3. Okay, that's very easy, right? So if you know the charge, for simple ion, if you know the charge, then that is the oxidation state. Some element almost always have the same oxidation state in their compounds. Some element, only some elements. For example, oxygens, hydrogens, and also fluorine. Okay, fluorine. But fluorine is not important in our syllabus. This one not important in our syllabus. Okay, so then only these two you need to memorize its oxidation state, because its oxidation state is almost the same every time. So with some exceptional case, okay, but it seldom come out in SPM. Okay. For examples, okay, the oxidation state of oxygen is always -2. Now this is for compound, okay. If for oxygen O2, this is element, O2 element, the oxidation state, this is an element, 0, yes, okay. For O2, the oxidation state is 0 because it's element, okay. But for compound, oxygens in a compound, the oxidation state is always -2. Okay, it's always -2, except what? Except peroxide. Okay, except peroxide. And the only peroxide that you need to know in SPM is this one, hydrogen peroxide. Okay, hydrogen peroxide. You have learned this in rate of reactions. This is hydrogen peroxide. Okay, hydrogen peroxide. Or you can write here if you want. You can write this hydrogen peroxide. This is the only peroxide that you need to know. Sorry. Okay, peroxide. Okay. Now for all others compounds, okay, the oxidation state of oxygen is always -2. Okay, for examples, H2O, the oxidation state of oxygen is -2. Sulfuric acid, the oxidation state of oxygen is -2. Zinc oxide, again, -2. Potassium chlorate, again, -2. Okay. Hydrogen peroxide, this one is different, okay. This one, the oxidation state is -1. Okay, so -1. Okay, yeah? So the oxidation state of oxygen is always -2 except peroxide. Peroxide seldom come out, okay, seldom come out. So if you can't remember this, is fine, okay. So just remember this. Oxidation state of oxygen is -2. Oxidation state of oxygen is always +1 except what? Except hydride. Okay, hydride is the negative ion of hydrogens. Hydride is a negative ions of hydrogens. Hydride, but hydride is not important in our syllabus. Okay, it's not important in our syllabus. I have been teaching for 14 years. I never come across this in SPM, so you don't need to worry about this. Okay, so again, okay, oxidation state of hydrogens in ammonia, +1, okay, +1. Hydrogen chloride, +1. Sodium hydroxide, +1. This is the oxidation state of hydrogens. Okay, now this one is hydride. Hydride. How do we know it's hydride? Because you see, magnesium, the charge is +2. Okay, so therefore the charge of hydrogen must be negative. Okay, actually it's -1 times two hydrides. Okay, so this is hydride. Okay, this is also hydride. Okay, because the charge of sodium is +1. So therefore the hydrogen, the charge must be -1. Okay, so that the charge is balanced. Okay, so for these two, the oxidation state of the hydrogen is -1 because they are hydride. But as I told you just now, in SPM, you don't need to worry about this. Okay, because so far I never see any hydride come out in SBM. Okay, so just remember that the oxidation state of hydrogen is always positive 1. The sum of oxidation state, for examples, water H2O. Okay, the oxidation state of hydrogen, positive 1. Okay, that's correct. Okay, and how about the oxidation state of this oxygen? Negative 2, right? Okay, negative 2. Okay, so the sum of the oxidation state, so we have two hydrogens. So two hydrogens, each one is positive 1. So 2 times positive 1, and then plus the oxidation state of oxygens, negative 2. So it's equal to 0, right? Positive 2 plus negative 2 is equal to 0. Okay, so the sum of the oxidation state of all the atoms, you see we have 3 atoms, 2 hydrogens, 1 oxygens. So the sum of the oxidation state of all the atoms or molecules in a neutral compound, because this water is a neutral, okay, and therefore the oxidation state is equal to 0. Okay, so the sum of oxidation state of a neutral compound is 0. Okay, for example, the sum of oxidation state of water, carbon dioxide, or ammonia are all 0, 0, 0. Okay, so that is the sum of the oxidation state. Okay, for hydrogen, the oxidation state is positive 1, oxygen is negative 2. But the sum, the total, the sum of the oxidation state is equal to 0. Okay, the sum of oxidation state of all the atoms in an ion, just now is a neutral compound, but this is ion. Okay, if it's ion, then the sum of the oxidation state is equal to the charge. Is equal to the charge. Okay, for examples, this one, okay, nitrate. I mean, what's the sum of the oxidation state of this nitrate? Negative 1. Okay, that's correct. Okay, because the charge is negative 1. Carbonate, negative 2, because the charge is negative 2. Okay, phosphate, negative 3, right? Okay, and ammonium, positive 1. Okay, so the sum of the oxidation state of an ion is equal to the charge. The sum of the oxidation state of each element is equal to the charge, and we can use this to find the unknown oxidation state or unknown oxidation number, okay, of an element in a compound. This is in a compound, not is a compound. In a compound, okay, in a compound. So what does this mean? Okay, for example, chlorate. Okay, so in this chlorate, this is chlorate 5, ClO3 negative. What's the oxidation state or oxidation number of the oxygens in this chlorate? Negative 2. Okay, yeah. Now, negative 1 is the sum of the oxidation state. Okay, sum of oxidation state means that the oxidation state of the chlorine plus the oxidation state of the 3 oxygen is equal to negative 1. The oxidation state of oxygen is always equal to negative 2. Okay, for oxygen it's always negative 2. Oxygen is always negative 2. Okay, then how about the oxidation state of chlorine? Okay, now we don't know the oxidation state of chlorine. Okay, we don't know the oxidation state of chlorines. Let's say the oxidation state of chlorine is equal to X. Okay, X. The sum of the oxidation state. Okay, we have 1 chlorine and 3 oxygens, right? Okay, so we plus 3. Okay, oxygen, the oxidation state is negative 2. So 3 times negative 2. Okay, what's the sum of the oxidation state of chlorate? Okay, X plus 3 times negative 2, this is the sum. Okay, so can you please tell me what's the sum of the oxidation state? Negative 1, yes, because the sum of the oxidation state is equal to the charge, and the charge is negative 1. So therefore, the sum of the oxidation state is equal to negative 1. So it means that the oxidation state of chlorine plus the oxidation state of 3 oxygens, 3 times negative 2, is equal to negative 1. Okay. So you see, now we built a linear equations. We have formed a linear equations, and from these linear equations, we can find the values of x, right? X is equal to -1, okay? This one move to another side. It will become +6, +6. And therefore, x is equal to +5. So +5. And x is the oxidation number of chlorine, right? So therefore, the oxidation number of chlorine is +5. So you see, that is how we find the oxidation number of the elements, oxidation number of an element, which the unknown oxidation number of an element. We don't know the oxidation number of chlorine, but we can find the oxidation number of chlorine by building linear equations, okay? By using the knowledge that we have about the sum of the oxidation state. Potassium manganate, potassium manganate. For this one, yep. What's the oxidation number of oxygen? Oxidation number of oxygens? -2, okay, that's correct. -2. Okay. How about the oxidation number of potassium? Potassium. Now, do you know the charge of potassium? Because we know this is potassium manganate, okay? It's formed by a potassium ion and a manganate ions, right? Manganate ions, okay? So the charge of potassium ion is +1, right? So therefore, the oxidation number of potassium is +1. Okay, +1. Okay, now we already know the oxidation number of potassium and oxygens. Find the oxidation number of manganese. Include the positive negative sign in your oxidation state or oxidation number. Okay, so the answer is +7. Okay, +7. So sum of oxidation number: potassium +1, manganese don't know, 4 oxygens, 4 times -2, and this is neutral, right? This is neutral, okay. So therefore, the sum of the oxidation number is equal to 0. +1 plus this is -8, so it becomes -7, -7. Is equal to 0, and therefore x equal to +7. Ammonium ions. Okay, so what's the oxidation number of hydrogens in these ammonium ions? +1. Okay, +1. Find the oxidation number of nitrogens. Okay, the sum of oxidation number: nitrogens, we don't know, x, and we have 4 hydrogens, 4 times +1, and the sum of the oxidation number is equal to the charge, +1. So x plus 4 equal to +1. So x equal to -3. So the oxidation number of nitrogen is equal to -3. Okay, very good. So this is a summary. For group 1 metals, in periodic tables, so the oxidation number is always +1. Group 2, the oxidation number is always +2. For example, calcium and group 2, for example, calcium and magnesium. Okay. Group 1, lithium, sodium, potassium. Okay, so their oxidation number, group 1 always positive 1, and group 2 positive 2. Okay, oxidation number for oxygen is always negative 2 except peroxide. Okay, hydrogen's always positive 1 except hydrides, which is negative 1. Fluoride or fluorine, fluorine or fluoride, okay, fluorine or fluoride, the oxidation number is always negative 1. Chlorine oxidation number is also usually is negative 1 except in compounds with oxygens and fluorine. Okay, for the last two, okay, it's less important in SPM, especially the last one. Okay, if you can't remember, then you can ignore this. If you can't remember, you can ignore this. For fluorine, always negative. I think this one you can remember. There should be no problems. Okay, so that's the summary.